Hello guys, welcome back to our channel. We will discuss about asset properties with examples in this video. We have already discussed AR model and its components in previous videos. Without any delay, let's get started. Now let's start with transaction. A transaction is a single logical unit of work that accesses and possibly modifies the contents of a database. Transactions access data using read and write operations. In order to maintain consistency in a database, before and after the transaction, certain properties are followed. These are called asset properties. Asset stands for atomicity, consistency, isolation, and durability. The image shows a quick view of asset properties. Atomicity ensures that the entire transaction takes place at once, or doesn't take at all. Consistency, the database should be in consistent state before and after the transaction, and isolation ensures that multiple transactions occur independently, without interference. Durability means, the changes of a successful transaction occurs even if there is a system failure. Atomicity. By this, we mean that either the entire transaction takes place at once, or doesn't happen at all. There is no midway, that is, transactions do not occur partially. Each transaction is considered as one unit L, and either runs to completion, or is not executed at all. Two operations are involved in this. Abort. If a transaction aborts, changes made to the database are not visible. Commit. If a transaction commits, changes made are visible. Atomicity is also known as the all or nothing rule. To understand atomicity better, let's see an example. Consider the following transaction T, consisting of T1 and T2, transfer of 100 from account X to account Y. If the transaction fails after completion of T1, but before completion of T, say, after write X, but before write Y, then the amount has been deducted from X, but not added to Y. Transaction failed after T1, and amount is not transferred to Y. This results in an inconsistent database state. Therefore, the transaction must be executed in its entirety in order to ensure the correctness of the database state. Consistency. This means that integrity constraints must be maintained, so that the database is consistent before and after the transaction. It refers to the correctness of a database. Referring to the example above, the total amount before and after the transaction T must be maintained. Total before transaction T occurs equals 500 plus 200, which is 700. Total after T occurs equals 400 plus 300 equals 700. Therefore, the database is consistent. Inconsistency occurs in case T1 completes, but T2 fails. As a result, T is incomplete. I stands for isolation. This property ensures that multiple transactions can occur concurrently, without leading to the inconsistency of the database state. Transactions occur independently without interference. Changes occurring in a particular transaction will not be visible to any other transaction, until that particular change in that transaction is written to memory, or has been committed. This property ensures that the execution of transactions concurrently will result in a state that is equivalent to a state achieved, if these were executed serially in some order. Let's understand this better with an example. Let X equals 500 and Y equals 500. Consider two transactions T1 and T2. Suppose T has been executed till read Y, and then T2 starts. As a result, interleaving of operations takes place, due to which T2 reads the correct value of X, but the incorrect value of Y, and sum computed by T2, X plus Y equals 50,000 plus 500, which is 50,500, is thus not consistent with the sum at end of the transaction. T, X plus Y equals 50,000 plus 450 equals 50,450. This results in database inconsistency due to a loss of 50 units. Durability. Durability guarantees that once a transaction is committed, and the changes are made permanent, they will persist even in the event of system failures or crashes. Committed changes are stored in non-volatile storage, such as disk, to ensure their durability. This property ensures that the database can recover from failures without losing committed data. The effects of the transaction, thus, are never lost. Advantages of ACID properties. Data consistency. ACID properties ensure that the data remains consistent and accurate after any transaction execution. Data integrity. ACID properties maintain the integrity of the data by ensuring that any changes to the database are permanent and cannot be lost. Concurrency control. ACID properties help to manage multiple transactions occurring concurrently by preventing interference between them. Recovery. ACID properties ensure that in case of any failure or crash, the system can recover the data up to the point of failure or crash. That's the end of this video. You now have understood what a transaction is and what ACID properties are. We will discuss about aggregate functions in next video. Stay tuned, do like, share, and subscribe for more videos.